Hey, how are you guys? So, as I said in my last little video, I did a display, PC display, similar to what you see at the top right-hand corner there for the BK Precision multimeter. And I did one for this Owon multimeter over here as well. Now, this one is very different than the BK Precision. This multimeter here actually has a version of the SCPI or SCPI protocol that many manufacturers use. Keysight, Siglent, and so on, they all support that. Originally, apparently, this was created by Hewlett Packard, probably like 30 years or more ago, and it has morphed into a standard that many of the test equipment manufacturers use. Owon has their own version, of course, and it's in typical Chinese fashion. It's full of bugs, but you can work around those. And this particular multimeter here, I'm not entirely excited about it, I must admit. It is very slow to respond when you're making measurements, especially capacitance. It can take sometimes like 20 seconds before it settles down. Anyway, but it is a relatively accurate little multimeter, and it could be handy to have two displays on my videos, maybe one for current and one for voltage or whatever. So I did one for that as well. So what we have is this. So there is a bug in Visual Studio 2022. Sometimes your designer, this is a WinForms application, and sometimes the designer doesn't show up at all, and at other times if you click on it and say select a panel or something, it comes up like this with a white background, and it's not right. But in any case, I made up a little window here with the couple of labels on it, and we have a timer that wakes up every now and then and actually sends a command to through using the SCPI command to the multimeter, and the multimeter replies with what's currently it has on its display. And of course, we've got a little menu here to start and stop it, and bring up the about box, and to set the COM port, and to exit, and that's about it. It's very simple. This code has ended up being a great deal simpler than the BK Precision was, because the BK Precision had a proprietary format that it communicates, and it just sends data just all the time, one after the other, boom, 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 and you got to kind of pick that up in the background, and then you have to see, did it actually change? If it didn't change, there's no point in updating the display, and so on. But with these using the SCPI commands, you actually control when the multimeter sends information. So it was a lot simpler. I didn't have to have a decoder or a background task to actually pick up the information, and so this was actually much simpler. Really not that much to say about it. Over here on the main form, it does still have the mouse move and so on, because I made it a window, a borderless window, and you can't see it over here because it has, maybe if I click this, yeah, there's a little menu button over there, and there is that little symbol over there means you can actually click on it and drag the window around on the screen. But most of the work is done in the Owon info class library, and you initialize that, and then you can say there's a couple of methods there, like, does it have receive an error? It'll be true. Is it ready to, is there something else to be displayed? It's ready to be displayed. It has the mode, like resistance, capacitance, and so on. Any error messages, like if has error is true, there will be an error message there. And the actual value to be displayed, and that's as simple as that. And it does have some decoding there, because it actually comes back with some for some of the values, like you can see over here. There, I turned the cursor on so it's a bit easier to see. Ohm, micro, and the temperature degree symbol there. It doesn't have the actual standard values for those characters like we would expect on the PC. It has its own codes, so you pick up these codes and then I can change that to an ohms or a micro or a degree C or a degree F Fahrenheit. And the value comes across as just a string of numbers, and you have to go and insert the decimal point. And these are the SCPI commands that I'm using. The measurement, show, question mark, it will come back with the actual value and what function is it currently got. It'll come back with a commands like resistance, capacitance, voltage, and so on. And of course we found a bug in there as usual. The Chinese, their hardware seems to be reasonable at times, but their software sucks. They really are not good doing that, and it's this multimeter, the firmware in there, it has a number of bugs. We'll have a look at that. So this is a function to get the SCPI data. After you send the commands, you can read it. Read measurement is the thing. Open the COM port. The baud rate and parity and so on, we don't bother to actually make it installable, because it is actually hard coded in the firmware, and it defaults to 15200 and so on, no parity and all that kind of stuff. This is the method that actually reads the data. Oh no, not this is the method that actually starts the object. Sorry, this is the constructor. This reads the measurement, and here you'll find this is the mode. So when we send that SCPI command to actually get the function mode that it's in, it comes back with these kind of strings: volt, AC, cur, AC, and I change them to something more readable. And this is when we find out that they got a bug. When it says continuity, it's really in diode mode, and when it says diode, it's in continuity mode. You would have thought that they would have picked it up pretty easily, but no one has been bothered to change the firmware, I guess. And the rest are good. And close the COM port. So it's actually pretty simple stuff. And I said it made much more simpler. Then I don't have to have a delegate and so on, like the BK Precision did for some background operations. So on that little menu, you can start it, you can stop it, reset the display, update the display when the form is loaded, so reset it, and we will start the COM port. If you're exiting the form, you close it. This is the mouse move stuff. This is the menu item start stop. So if it is started, then stop it, otherwise start it. More mouse stuff to for moving. If the COM port is clicked, then show the about box and save it if anything's changed. And here we have the update timer. I think I got it set for 5 times a second or something like that. And if it got some data, then update the display. So as I said, that's pretty simple. Now I published this to GitHub, so you can actually get the code, and it is over here. Here's the VK390A display software is there, which is a little more complex, and this is the Owon display over here, where you can actually get the code. And let me see now this here. Oh, let me actually go back here. There should be, when you go to the Owon website, www.owon.com HK, they have a section here for downloading PC software. And when you download that, you will end up with a zip file, and in there you will find a driver for the port. Okay, so this is the archive that you download from the Owon website, and in there is that DMMEasy control software that you can install. But the main important thing here is that it has a Windows driver there. This is for the CH340X installer, which is the USB to virtual COM port driver. And you will need that if you're going to run the software that I created, because it uses that in the background to expose a COM port for the USB port that you're using to plug the device into. And that is where that comes from. And in there you can download the programming manual, which is what this is. It talks a little bit about the SCPI commands. There's a couple there to start with: the start, a general purpose one, to clear, identification, reset, and all that kind of stuff. And those commands tend to be like 4 letters, and they make those uppercase here to show that that is the minimum number of letters you got to use. But you can either type the full word here, sense, or you can use SENS. And given that programmers and technical people usually are lazy, like me as well, I would just type CONF and forget the IGURE for configure, And so that's why these things are in partly in uppercase and lowercase. That just denotes that you can use the shorthand version or the longer one. Let me see now. So here just talking about the in the commands that you use, spaces use separated command and a parameter. Colon, if the colon is in front of the first character, it means the following is a root command. When the colon is between 2 keywords, it means moving from the current level to the next level. So in other words, you can separate commands on one line, multiple commands, with separating them with colons. and you can either put a colon right up the front or not have it for the first command. I have found if there is an asterisk, then it's a common command used to execute the IEEE 488.2 common commands. So this SCPI thing has been accepted by the ANSI standard people, I think, that, or IEEE rather, standard people, and they have assigned a number to it. And it sometimes uses braces, vertical bias, and so on. I am not using many of these commands, as you saw in the source code. I am only using a couple of those. They were right at the top here. Or maybe not. Oh yeah, there they are. To get the measurement and the function. You see, so measure, colon, and the next command is show, and when you put a question mark on there, it becomes a query. So the onus is then on the multimeter or the device that you are connecting to actually return something. So you want to know what the measurement is, and the show command actually gives you that format of the so I found that you can use this document, but it's very long-winded and has a lot of information, and of course some of the information in there is kind of incorrect because it's got bugs. So I found another document which I actually found a lot better to use, and this is page 7. Somebody has gone through this whole thing and tested all these commands. Okay, so I found out where that I got that document from. I remembered now. I got it from a GitHub site, the TheHWcave. So I decided to insert this little piece into the video after I made the video. And this individual here has a Owon section, and he actually has some firmware that he put up there that he got the permission from Owon, but I'm not going to go there. And the document that I had is this one over here, XDM1041 SCPI PDF that we were looking at. So this is where you can get it from. I'll put a link in the description as well. I'm thankful that this person has actually done this and actually made a much better document than the Owon people have. And in there you will see much more clearly, you know, if you output mesh question mark, what it returns, and if you put show there, which is the one I'm using, shows the same value as measure12 alone, but formatted as displayed and with unit. That's right, yeah, I remember now. I earlier said that you had to insert the decimal point, but you don't when you use this show version. However, the format of it does need a little bit of decoding, because as it says here, the ohm, the micro, and the Celsius and Fahrenheit values need to be decoded from those codes. And in various places, you see there is a thing that this person has noticed. If I'm not using those, I'm not actually controlling the multimeter. You can, of course, but I'm not doing that. And here's another bug. If measure selected, the temperature value returns. This is you know, for the temperature. It's no longer updated and all that kind of stuff. And as I said, this one here, this is a bug that is newer than what this document is, because this document I think was 2021 or something. But I found that when it outputs cont, it's actually in diode mode, and when it outputs diode, it's actually in continuity mode. So that's another bug. And here there's a little bug. So as I said, that the firmware on this thing is buggy, and the actual multimeter itself is kind of slow. And I must admit, I cannot recommend this multimeter. They need to do some work on it. They need to get it faster controller, microprocessor, whatever is in there. And of course, it would be good if they got rid of some of these bugs. So right now I've got a resistor connected to it, as you saw. If I set it to voltage, if you watch the display at the top there, see now it changed the voltage. This is a spent battery, so I don't know, I think it's spent anyway. Oh no, it's actually a good one. 1.5938 volts. Voltage DC. What else have I got in here? Not much. This is some sort of this is another resistor. $100, 180 ohm resistor according to the color coding. This is 188.4, and it's 5%. So you know that's kind of how it works. You can select temperature. Do I have the no, I don't know what I've done with it. I don't have a temperature probe connected, so it's not going to give me a good reading. But as you can see, it's working. It's interesting that the information that it outputs is more accurate, or it has more digits behind the decimal point than what the one on the display does. Anyway, so that's it. So the reason why I actually did this is this actual software that they supply with it, and I have used it a few times, but it also is kind of low quality software. You go to Control Connect, and then very unintuitively it's actually connected via a USB cable, so you think that you can connect via USB, but no, you have to select this thing here via COM, USB COM. Then you wait for a little bit, and then you will see a bunch of COM ports here. Now I know that it is on COM 10, but if you select the wrong COM port and you select OK, then either nothing happens, or see, it's not responding, it actually hangs, or sometimes it crashes, it's gone, you have to run it again. And it's very easy in the software to know whether you're connected to, if that's the right port. You send a SCPI command to say, hey, identify yourself, and if nothing comes back within a third of a second, you know that it's not working, or maybe the port's not connected at all. So you have to kill it. Okay, so it's back. So if I now select the right COM port, so this is the display that you get, and I didn't like that display because it has this tiny little thing there, Celsius, and if you want to display this on OBS Studio, you can actually clip this piece out, but then you got this whole empty area you got to include, and I don't care about this trigger thing and so on, and it didn't suit me, so that's why I did my own little application there, so I can put it on the top of the screen when I'm doing these videos and stuff. And it does have these buttons. You can actually, as soon as you run this software, the actual multimeter now is in remote control, so none of the buttons work on the panel and stuff. I don't want that either. You can turn that off. You can push the local button back on the multimeter, but it just didn't suit me, and it's kind of buggy, and I wonder if they fixed the. Okay. Yeah, you see, it's not even working properly. I'm in continuity mode right now, and it still says temp. And now I'm in diode mode, and it still says temp. So as I said, it's a crummy piece of software. That's why I did my own. See, if I go to my own software here, start. Here it says diode mode open, which is exactly what it has on the screen. See? Function, diodes, and open. My software works properly, theirs doesn't. Anyway, that's about it. I will put information in the description here about where the a link to the pages and things for the Owon, and also the GitHub page that we can see. This one over here. All right. Now, don't forget to click the subscribe and like and the little bell thing and all that kind of stuff, because that would really help me. Doesn't cost anything, so I would appreciate it. And I'll see you for the next video.